Welcome to our video series, Everything About Public Schools. My name is Blaine Helwig, and today's focus is an essential base 10 numeracy skill, counting up to make 10. Again, welcome and glad to have you along. Counting up to make 10 will cover grades 1 through 6. There is a free downloadable PDF under the video tab at www.the new3rseducationconsulting.com, or you can Google my name, Blaine Helwig, and follow the links. Let's get started. Making 1, 10, 100, 1,000, or 10,000, of course, is going to build student numeracy. But let's define numeracy. Mathematical numeracy can be thought of as is word fluency and literacy. Students need to be able to recognize basic words with automaticity as they read or their comprehension suffers. Analogously, students need to be able to reason mentally and effortlessly with numbers in a variety of worldly situations commonly occurring in everyday life to be deemed mathematically numerate. What does numeracy look like when viewing a student's mathematical ability? A numerate elementary student can readily use the 4 arithmetic operations: addition, subtraction, multiplication, division. They can grasp improper and proper fraction, mixed numbers, decimals, and their interrelated connections. They can recognize even and odd and prime composite numbers, understand measurement quantities, and estimate distances. They can half and double whole numbers, etc., etc., etc. And, most importantly, they can apply them in problem-solving situations. How should numeracy be taught in the classroom? Intentionally with purpose, of course. As both kids and adults learn with age, good things rarely happen repeatedly by accident. They happen because someone, and in our case, a professional educator, a teacher, knew what they were doing, they had a plan, and they practiced. Or, as pro golfer Gary Player once said, the more I practiced, the luckier I got. Making 1, making 10, making 100, yes, these are all vitally important numeracy skills for students to learn, but the question needs to be asked, why are all these making 1 and 10 skills so important? The answer is easy. Because we live and interact in a base 10 world, the need for this numeracy skill is all around us. Therefore, educators should know the why, which we just covered, the when, the what, and the how of making 1, 10, 100, 1,000, and 10,000. The when, where each of these making 1, 10, etc. numeracy skills should be taught, are provided in the table below. Off to the left, you can see the grades are listed vertically, and at the top horizontally, the making series are listed. The table looks complicated, but it's really not, because grade 4, 5, and 6, all numeracy skills are taught, whereas grade 1 and 2, it's just a modified for making 10 and making 100, and grade 3 has some specific skills, making 10, making 100, and then making 1,000 and 10,000 level A only. The good news is that these practice sheets available for free download are carefully delineated so each sheet is labeled for the grade level that was intended to be taught. The what in the Making 10 numeracy series basically boils down to what practice sheets are needed. This has 3 main points. First, it obviously depends on the grade level. Primary grades will have a different level of complexity than intermediate elementary grades for developmental reasons. Second, it depends on if there's a global numeracy program at a campus. For instance, all sequencing and accountability issues are resolved for prior grades if a numeracy program like Formative Loop is used, since that program guarantees exposure and student mastery at those prior grade levels. It also acts as a general sequencing guide, which is especially helpful for entry-level teachers. Third, again, I have posted all the practice sheets delineated by grade level for free at the New 3Rs Education Consulting, or Google my name. Follow the links to the website's video tab. The main point here is that this eliminates 98% of the demanding and labor-intensive teacher preparation, so the teacher planning time is greatly minimized. And finally, the how to pedagogically accomplish student mastery in our Making 10 numeracy series. Of course, our teaching goal is always to make all students successful, and this objective can be accomplished for all students to high levels in any school setting with highly effective teaching methodologies, resources, and systems, as well as assisting any students receiving special education services to successfully meet their IEPs, their individual education plans. So let's discuss the main fundamentals of pedagogical sequencing and lesson design. On any newly introduced mathematics concept, the sequencing should always be a tactile manipulative, then it moves to a pictorial lesson, and then finally paper pencil in that specific order. Let's give some examples. Number 1, addition, subtraction, facts. In the primary grades, a teacher will begin with some type of a tactile manipulative, maybe buttons, then move to a pictorial, and then finally to paper pencil. However, in the intermediate grades, 3rd, 4th, and 5th, the teacher will just begin with a numeric exercise. Area polygons, parallelograms, squares, rectangles. In 3rd grade, it's a newly introduced mathematics concept, so the teacher begins with a tactile manipulative, possibly 1 inch by 1 inch ceramic tiles, then moves similarly to a pictorial, a parallelogram with 1 inch by 1 inch or 1 square unit squares occupying the insides of that particular parallelogram, and then moves to paper pencil. Contrast that with 5th and 6th grades, the student would just be given a rectangle or a square with a length and a width, and the student would simply multiply those 2 dimensions to compute the area. So let's begin by making 10. Our goal is how to teach this skill to obtain student mastery. It's highly recommended that the viewer act as a student and actively engage and participate to ingrain the process. Making 10. Let's begin in the primary grades. Since this is a new mathematics concept, we need a tactile manipulative. Manipulative options are coins, especially 1-cent pennies, small colored plastic discs, hands, etc. Personally, I recommend hands, 10 digits, 5 per hand, plus the student always has this manipulative with them 24/7, and there's no prep time required. It's highly efficient. So let's do some examples of making 10 using our hands as a manipulative. So the teacher would show students 9 digits. Students respond with 1 digit. 9 plus 1 is equal to 10. The teacher shows students 8 digits. Students respond 2 digits. 8 plus 2 is equal to 10. The teacher shows students 10 digits. Students show their teacher 0 digits. 10 plus 0 is 10. The teacher shows students 7 digits. Students respond with 3 digits. 7 plus 3 is 10. I strongly recommend that teachers confine their mini lessons or spaced repetition instruction for the first 3 or 4 days using only the numbers 7, 8, 9, and 10, meaning 7 plus 3, 8 plus 2, 9 plus 1, and 10 plus 0. This quick and engaging daily instruction will provide students threshold repetitive practice to ingrain those number combinations into long-term memory. Then, after those addition combinations are mastered, add in 5 and 6, meaning 5 plus 5 and 6 plus 4, and include the first mastered set of 4 numbers, 7, 8, 9, and 10. Continue until mastered, and then add in 2 and 3, 2 plus 8 and 3 plus 7 to the mix. Repeat until student mastery is achieved. Finally add in 0, 1, and 2, and repeat the process until students demonstrate making 10 mastery of all digits from 0 to 10. There is no hurry here. Time is on your side, so get slowly rich with your instruction. Let's do a couple more examples of making 10 and move on. The teacher shows students 4 digits. Students respond with 6 digits. 4 plus 6 is 10. The teacher shows students 0 digits. Students respond with 10 digits. 0 plus 10 is 10. Now that the tactile lesson is completed, let's transition to the pictorial pedagogy. I recommend the Making 10 dot approach. It's a resource that is included with the free download of all practice sheets. An example of it is shown to the right. Advantages of this pictorial resource are the following. It's free and easy to use. It incorporates the missing add-in skill. It exposes the students to equations. And it transitions finger manipulative to a dot pictorial representation of the same mathematical thinking. Now that the tactile and pictorial lessons are completed, the paper pencil stage has finally arrived. I recommend using the Making 10 resources included in the free download and build up to the Middle Math final assessment. One of the build-up exercises is an equational level A process where the student just fills in the missing add-in. It's shown to the right. The final assessment is the student just needs to mentally recognize the pairing of the numbers. So you see 10, 0, 9, 1, 8, 2, 7, 3. The student would see 6 and recognize that 4 is the pairing to make 10. Teaching tips in using these resources. Prior to using the final assessment resource, use the Making 10 equation resource and practice with the students. That was the resource that was shown just before the one to the right. Then write a series of numbers vertically in boxes as shown to the right, the final assessment, and pre-practice them so they're ready for the assessment. B. Emphasize number pairs that sum to 10. 9, 1, 1, 9, 8, 2, 2, 8, 7, 3, 3, 7, 6, 4, 4, 6, and 5, and 5. Speed means automaticity. It should be timed. First grade is 3 minutes, and second through sixth grade is 5 minutes. If the students have been properly prepared, there will not be anxiety in worrying about a time test. Making 100 and making 1. How to pedagogically accomplish student mastery of these two numeracy exercises. How to make 100, student mastery. Once students completely master making 10, the other making numeracy exercises are fairly straightforward in pedagogy, since they are A, also a base 10 origin, and B, they are fundamentally dependent upon a student's ability to adeptly and automatically make 10. Hence, a student's ability to mentally sum two one-digit numbers to 10 open the door to tremendous arithmetic numeracy benefits. Making 100 is a three-step process. It can be done in 2 iterations, but this is a new exercise to 3rd, 4th, 5th, and 6th grade students, so it is broken into 3 steps to make the transition easier. As a seasoned elementary teacher knows, making 100 and making 1, i.e. 1.00, are the same exercises except the latter is using decimal numbers. However, it is highly recommended to begin the process with whole numbers, making 100 first. Making 100, level 1, summing 2 numbers to 100 from any multiple of 10. Since this exercise is a direct correlation to making 10, students will master the numeracy skill quickly after the teacher shows that making 100 is the same as making 10, except they must add a 0 in the ones place. For example, the resource sheet shown to the right is the final assessment. Again, automaticity requires speed, timed, 5 minutes. As long as the students are properly prepared, finishing this numeracy exercise will not be an issue. The recommended mastery level is indicated by a black star located on the resource sheet's answer key. Making 100, level 2. Sum 2 whole numbers to 100 from a multiple of 10 or a midpoint of 5, meaning 5, 15, 25, 35, etc. Why is this important? Because it assists students in 2 ways. First, it significantly improves students' rounding skills to the nearest 10. Second, it is a controlled adding up methodology using base 10 mathematics that greatly augments students' general numeracy awareness. The final assessment can be viewed on the bottom right of the screen. Students are given a number in the left column, and in the right column, they are required to compute the missing number that adds to 100. It is important to note that it makes zero instructional sense to give students a final assessment like this one without adequate preparation and practice. The task will be overwhelming to a vast majority of your students. Hence, I recommend using a pictorial diagram to help students visualize and understand the adding up process to make 100. It's easiest to draw a quick number line and label the salient numbers until students can mentally visualize the process. I also recommend students draw the number line concurrently with their teacher during the mini lesson or spaced repetition exercise. It greatly assists in their ability to ingrain the process. So let's try an example. Let's make 100, meaning add to 100 if we are given the number 35 as a starting point. The teacher and students should draw a quick number line. Add 3 short vertical lines and label the lines. The first 2 lines are relatively easy to label since students are given the number 35. 35 is between 2 multiples of 10, 30 and 40. Let's add those numbers to our ad hoc number line. Then add 100, our ultimate goal. Then we can go and add 35 to the number line. At this point, we are back to the simple exercise of making 10. The distance between 35 and 40 is 5 spaces, and the distance between 40 and 100 is 60 spaces. We simply sum 5 and 60 to arrive at 65. With 5 to 6 quick examples a day for 3 to 5 days, students should become very adept at this exercise from only a prerequisite base 10 content knowledge of making 10 using one-digit numbers. Making 100 Level 3, summing two numbers to 100, given any whole number between 0 and 100. This exercise develops general numeracy ability with whole numbers, and it gives students the ability to compute distances from any quarter or half point. The final assessment can be viewed on the bottom right of the screen. Students are given a number in the left column, and in the right column they are required to compute the missing number that adds to 100. Use the pictorial number line to help students visualize the numeracy mechanics. Draw number lines until they can mentally map the process. Example, make 100 given 83. The teacher and the student should draw a quick number line, add 3 short vertical lines, and label the lines. The first 2 lines are relatively easy to label since students are given the number 83. 83 is between two multiples of 10, 80 and 90. Let's add those numbers to our number line. Then add 100. Let's go back and add 83 to the number line. At this point, we are back to the simple exercise of making 10. The distance between 83 and 90 is 7 spaces, and the distance between 90 and 100 is 10 spaces. We simply sum 7 and 10 and arrive at 17. With 4 to 6 quick examples a day for 3 to 6 days, students become very adept at adding up to 100 from any whole number between 0 and 100. Making 1, levels 1 and 2, summing 2 decimals to 1.00, given a multiple of 10 decimal, level 1, or any decimal between 0 and 1.00, which is level 2. Yes, it's a base 10 world and it comes in handy here. So this is the exact same exercise as making 100 using 2 whole numbers. Thus, in this case, we only need 2 levels, L1 and L2, to achieve student mastery for making 1.00. It's again the same methodology and pedagogy for making 1 as with making 100. Multiples of tenths L1, that resource is shown here. Any given decimal L2, and that resource is shown to the far right. Use the number line approach as we did with making 100, and it is highly recommended to master making 100 before trying to make 1.00 with decimals. Making 1,000 and making 10,000, how to pedagogically accomplish student mastery on these 2 numeracy tasks. Making 1,000, 2 levels, A and B, summing 2 whole numbers to 1,000 from multiples of 100, that's level 1, and mid-100 points, 50, 150, 250, 350 to 950, that's level 2. Making 1,000 level A. At this point of the numeracy making series, after the teacher demonstrates the process, students invariably grasp the physical numeracy skill and minimum student practice is required for mastery. That resource final assessment is shown in the bottom right. Making 1,000 level B. Use a number line approach as before until students mentally master the process. That final assessment is also shown to the right. Let's work an example. Given 650, let's make 1,000. Students and teachers both draw the number line and fill in the numbers. 600, 700, and our goal of 1,000. Come back, fill in 650, and straightforward from here. 650 to 700 is 50. 700 to 1,000 is 300 spaces. Simply add 50 plus 300 and arrive at 350. Making 10,000 levels A and B. Sum 2 whole numbers to 10,000 from multiples of 1,000, level 1. And mid-thousand points, 500, 1,500, 2,500, that's level 2. Making 10,000 level A, students immediately grasp the physical numeracy skill with minimum practice, but many students have difficulty writing numbers that large. Please take that into account on the final assessment, which is shown at the bottom right. Making 10,000 level B. Use the number line pictorial approach as we have done before until students mentally master the process. The final assessment is also shown to the right. Let's work an example to demonstrate the process. Given 8,500, let's make 10,000. Students and teachers both draw the number line and fill in the necessary numbers. 8,000, 9,000, 10,000. Come back in, fill 8,500, and from this point it's straightforward. 8,500 to 9,000 is 500. 9,000 to 10,000 is 1,000. Simply add the numbers. 500 plus 1,000 is equal to 1,500. Final comments. Let's sum up the main points of the Making 10 video with a couple of the major takeaways. First, numeracy development must be a planned and structured process at the elementary and middle school levels. 2, All student opportunity exercises referenced in this video are available for free download. Google my name, Blaine Helwig, and follow the links. 3. In that free download, I also wrote and included a recommendation for effective use to further assist an interested educator. Fourth, the Making 1-10-100 series will assist teachers in building the following numeracy attributes for each student. A. Students gain a general number sense of base 10 mathematics. After completing this numeracy series, students' numeracy ability will astound their teachers. B. Students can readily locate quarter and half points in both decimal and whole number forms. C. It facilitates understanding with rounding whole numbers from the nearest 10, 100, and 1000, as well as assisting students with a better understanding of the estimation process, as well as evaluating the reasonableness of solutions. Thank you for watching. I hope this short video was helpful in your work in the public schools. Please check out our other videos and resources.